We are talking about solving quadratic equations by completing the square. And we look here and we see 3x squared plus 6x plus 9 equals 0. And the first thing that we want to do is we want to get rid of our c value. So I'm going to subtract 9 from both sides of the equation. And we're going to get 3x squared plus 6x is equal to negative 9. But we're going to have to add some c value to both sides of the equation. The other issue that we notice here is our a value is 3. So on the left-hand side, what we're going to do is we're going to factor out a 3. So 3x squared divided by 3 is x squared. 6x divided by 3 is going to be plus 2x. And on the right side, we're just going to leave that alone. But we're still going to have to add some c value there. Well, in order to calculate our c value is going to be equal to our b value divided by 2 and then squared. In this case, our b value is positive 2. So 2 divided by 2 is 1. So it's going to be 1 squared, which is equal to 1. So again, we have to pay attention to what values are we actually adding. So if we do add a 1 to the left side, that's saying 1 multiplied by 3. So if we distribute this back, 3 times x squared is 3x squared. 3 times 2x is 6x. And 3 times 1 is 3. So we're adding 3 to both sides. So on the right side, we also have to add 3. Now we can rewrite it in a form, in our binomial, our perfect square binomial. So we still have the 3 in the front. And the only things that multiply together to get us x squared are going to be x times x. And right here, whatever this value we're squaring goes in to our binomial. And then we have negative 9 plus 3, which is negative 6. Now we can rewrite our binomial as a perfect square. So we get 3 times x plus 1 quantity squared, and that's equal to negative 6. And from here, we want to solve to get x by itself. So we divide both sides by 3. And then we get x plus 1 quantity squared is equal to negative 2. And then we want to take the square root of both sides of the equation. And the reason we did that is our square root cancels our square. And then we're left with, on the left-hand side, we're left with x plus 1. And on the right-hand side, we're left with plus or minus the square root of negative 2. So we should be thinking, well, square root of negative 2, we don't really like that. So we should rewrite that. And another way to write the square root of negative 2 is to say plus or minus the square root of 2 times the square root of negative 1. And we know that the square root of negative 1 is I. So this becomes plus or minus the square root of 2I. So all we did was we just simplified the right side of the equation. So we'll move our work up here. The left side is still x plus 1. And the right side is equal to plus or minus 2i. the square root of 2i. And now we simply subtract 1 from both sides. We cannot combine these like terms, or these terms, because they're not like terms, so we cannot combine them. So we get -1 plus or minus the square root of 2i. And that is our simplified answer. We have another example, example 9. Again, we want to get rid of our c value. So we're going to add 18 to both sides of the equation. And then we're going to get 3n squared plus 12n plus some c value is equal to 18 plus whatever that c value is going to be. Another issue that we have is our a value again is not 1. So we're going to factor 3 out of the left side of the equation. So 3n squared divided by 3 is n squared. 12n divided by 3 is 4n. We're still going to have that c value. And we'll still have to figure out from there. So next, we want to calculate what our new c value is going to be. So c is equal to the b value squared. The b value divided by 2 squared. In this case, the b value is 4. So 4 divided by 2 is 2 squared. That is equal to 4. So again, we have to pay attention. We substitute in a positive 4 on the left side, but we have that 3 that's multiplying by that 4. So 3 times n squared is 3n squared. 3 times 4n is 12n, and 3 times 4 is 12. So we're adding 12 to both sides. We added a 4 to this trinomial, but this trinomial is getting multiplied by 3, so really we added 12 to that side. Now we can rewrite our equation because we wanted to get that perfect square binomial. So we have 3. So the only thing that's going to get us n squared is going to be n times n. And the only thing that's going to get us to 4 is that value that we squared right here, which is 2. So we're going to add 2 to both sides. And then on the right-hand side, we have 30. We can rewrite this again. We get 3 times n plus 2 quantity squared is equal to 30. Now we can divide both sides by 3. And then we get n plus 2 quantity squared is equal to 10. And then we can take the square root of both sides. The radical cancels the exponent. And I'm going to write this over here to finish out the problem. So the radical and the exponent cancel. We're just left with n plus 2. And then that's going to be equal to plus or minus the square root of 10. We cannot simplify this radical. So what we do is we subtract 2 from both sides. And we get n is equal to -2 plus or minus the square root of 10.